So let us continue. Here we have a cable, and look at this. We have a home, so it's home, and this is the office of maybe some providers. And furthermore, we want to let you have the detail of the cable. We have a hybrid fiber coaxial cable, and we call it HFC, so it's a cable. And this kind of a cable, it is the symmetric cable. It's asymmetric. And asymmetric says we don't have the equal bandwidth. We'll have bandwidth, for example, here. It doesn't mean this is the newest one, but we set it to maybe a few megabits per second to 1 gigabits per second. And this is a downstream transmission rate. Downstream says we want to, for example, get a large file. So we'll have a larger bandwidth here and a smaller bandwidth for the upstream. Upstream says we want to send a request, something like, can you send a file for me? So this is the question to request. And then we send a large file to the client or to the customer. So we have the asymmetric rather than the symmetric cable. Here we have HFC. Because we think for the user, normally they send a request simply, and then we need to download the file. But you may have a question. Is it possible to allow you to upload a large file to the internet and then distribute the file to the other customer? It is possible. It is possible, but we think normally we should have a way send a request and download the file. As for the other side, you want to upload a file. Sure, you based on the possible transmission rate to upload your file. But think about this. Send a request is easy and most of the possible scenarios. So we have the smaller capacity for the upstream transmission rate. Even sometimes you want to have the file to upload. Well, so we have HFC, all right. And we talk about home network or residential network. So we use shared access network. Well, we have a cable to enable residential or home access network. Is it possible to base on DSL, digital subscriber line, based on the phone network? It says yes, right? Yes, and then this is a way to have a home access network through DSL. So we have previously it's cable, so we have a cable modem. Well, modem actually it's modulation and demodulation. Modulation and demodulation. All right. Sometimes my pen cannot work properly, so I didn't know demodulation. So we have a modulation and demodulation, so that we have a modem, right? So modem actually we have one operation, modulation, and then the other one demodulation. And currently I stop here. If you are interested in the meaning of modulation and demodulation, you can look up through the internet, then you know that one. And of course we have a splitter similar to the previous one, but right now it's DSL. So DSL, so we have a telephone network. And here we have office, and this office we call central office. We have a home and we have a central office. And this is a DSL, access multiplexer. So multiplexing, put them together, we have a multiplexer. All right, or maybe if we want to have the simple term, maybe we collect all. So we have a collector, but we have the specific name. It's called a multiplexer. Well, for this one, we use existing phone line. Sorry, maybe something wrong, but I just point out using my current pointer. So we have the existing telephone line, and this kind of telephone line for data transmission, so that we have a name here, digital subscriber line. All right, and so that we can provide data. And previously we provide data, but later, after the idea of a DSL, we also provide voice, provide a video, so we have a multimedia. And because of phone network, so checking the rate, yes, we have the asymmetric one, but I should draw your attention to check the capacity for DSL and capacity for cable. Which one larger? Of course, cable provide a larger capacity, but for DSL actually a smaller one. Well, this is a residential access network. We can pass on cable, we can pass on DSL. And right now, we just look at the details of your home. You can have AP. So this one, in fact, AP, we can call the function of AP serving as the switch. And then you may have you on maybe still you call switch, or you can call it a router. And actually this one connects to the edge router of the access network. Well, this is a possible scenario. So you have a cable or modem or DSL. And you have a router, you see? Normally we use this one to serve as a router, and here it should be access AP access point, or it called the switch, right? What is Wi-Fi access point, AP? And AP actually is a function of switch. And for this one, I don't know, it's layer 2 and this one layer 3. Well, I don't know, later when we reach these and we can let you know the protocol layer, so that what it means layer 2 and what it means layer 3. Well, so we have all this, and so that we have the possible component within your home. And also, here we have the combined version in a single box. So it doesn't mean we should have the split version like the current one. And actually we can have the integrated version, and that integrated version maybe you simply call, okay, you have a router to provide all the functions here. Well, that is a residential access network. And right now we already have the wireless access network. And same, wireless access network, we can have a Wi-Fi, we can have the cellular network. So, dedicated for you? No. So we have the shared wireless access for Wi-Fi or cellular network. Cellular says we have a cell phone, right? So cell phone, then we have the cellular network. And if you use Wi-Fi, you know Wi-Fi, right? You have a Wi-Fi AP, and then we have a Wi-Fi. And right now, we check this. What is local area network? So we have WLAN. And if we use this, actually it's called Wi-Fi. Wi-Fi means wireless fidelity. But why previously we want to use Wi-Fi to service us the technology? I'm not sure, but you can check it for detail why we use Wi-Fi. But we always call Wi-Fi, but it's wireless fidelity. So we have a Wi-Fi. If it is Wi-Fi, here we have IEEE standard. So we have IEEE L2.11b, and all the others. And so that we have the different physical rates. And here we can have 11, we can have 54, we can have 450 megabits per second transmission rate. You can check B, G, and N. So we have all of the possible rates for Wi-Fi. Well, actually we can have Wi-Fi. And how about cellular here? Cellular network, for example, 5G. Why 5G are coming? In fact, this is a possible maybe around 2020. So we have maybe the status 5G coming. In fact, we have a 5G already, or even we want to expect 6G coming. Well, we have that kind of cellular network, but cellular network and Wi-Fi, what's the difference? Local area network. So the short transmission range, and 4G actually we have a wider transmission range. So we have a wide area cellular access network. Or maybe we have a WAN, wide area network. Well, so the difference as says short transmission range, a larger transmission range. So I think you can know the difference, the salient difference between Wi-Fi and 5G. Well, so that is the wireless access network. We already have the possible technology of Wi-Fi and 5G, not 4G. Currently, we still have 4G. Yeah, it's true. But 4 or 5G. In the future, maybe 5 years later, perhaps we have a 6G. Normally, 10 years or a decade, then we will have a new generation for the cellular network. Well, for enterprise, for the institutional one, companies, university, I think you know all this. So I double check the description here for 1 minute, and then we check the next. Well, I just want to stop to double check. It doesn't mean I speak a lot. I saw that bombard all of you. So let you have time to think about this. 然后稍微停下来，让各位去看一下、想一下，不然都是一直说在轰炸各位。All right, so I think you know all this, but compared to so wait a moment. So almost the same, but we have Ethernet, right? And we have a Wi-Fi, but why we don't have a 4G, 5G? Actually, you focus on Ethernet and Wi-Fi simply for company or university. It doesn't mean for the university you are pushed to use 4G or 5G, right? So we do not include 4G or 5G. So about Wi-Fi the same, but about Ethernet and Wi-Fi, you know, higher capacity for Ethernet. So we expect to use Ethernet possibly. All right. And we have a different rate. And then we already have one possible definition like this. Well, if we want to exchange the message, let's say we want to exchange packets. And then how to have the possible time. And the current time we call later transmission delay. So before that one, we already have some possible definition. Packet, if we have the fixed length, maybe we have L to serve as the length of the packet. And we have a transmission rate, R, or maybe we can call its capacity. I didn't know capacity previously, so it's true. Transmission rate, aka says also known as. So we have aka, that says a different meaning of different term, capacity. Capacity, aka link bandwidth. So we have a transmission rate, link bandwidth, O, transmission rate. We have R. And R serving as the link transmission rate. So we have a link here. All right, link between host and the router. So we have a link. And we have a packet L. So transmission rate given and length of packet. So that we have the definition, packet transmission delay. And packet transmission delay, then we have the formula L over R. If we check units, L we have beats, R we have beats per second, so finally it's time. So of course it's a time. Possible type of time, and this type of time we call transmission rate. Transmission rate, something like we want to move the packet from our house to the transmission line, and the time it is called the transmission delay. Maybe you have another question? Well, I put the packet to the link, and then the link should move to, for example, to the router. So the current transmission delay defines the time from the end near the host to the router. So let me mention the time. Well, time actually move the packet from the host to the transmission line. And another time move the packet from the point near the host to, maybe not move, to the router. So should the two types of time the same? And right now, let me mention in Chinese. 我刚刚说了一个时间是把这个 packet 从这个 host 拿到这个 transmission line 时间1，然后这个 packet 从这个端跑到这个 router 时间2。所以两个时间有没有一样？不一样。So I then have two types of time. The first time, someone like move the packet from the host to the transmission line. It is a type of transmission delay. But the second one not the same as this one. What it means, later we will have the propagation delay. So the second time it is called the propagation delay. And later we will already have a propagation delay. But before that one, I should already have a packet. But right now I already have the key term packet here. In Chinese, we have the first one in Taiwan, but in China, maybe they prefer the second one, or maybe the others. However, we have the definition in English, a unit of data that is sent over the computer network, and then we call it is a packet. Well, later we will that we have the second type of time, but I don't know the name. It's called the propagation delay. And we don't know this definition. Later we will have the detailed discussion about the transmission delay. And let us continue. Well, we talk about the packet. So how to have the packet? Actually, we have the packet. We have maybe a size of bits. So you know bits propagate between the transmitter and receiver. Here we already have a term, propagate. Previously I asked you if we have a packet. Actually, it doesn't mean move. The packet will propagate to the router, and that time it is called the propagation delay. And right now we call a simple one. We have a bit within the packet, so we have a bit. Bit actually will propagate. Yes, we use a proper term for this one. Propagate between the transmitter and receiver pairs. Of course, this one propagate within the physical link. And physically, we have the others. And we have a line, and then we have a guided media. If we don't have the guided uncontrolled media, and then we have, for example, radio or Wi-Fi, the other. So we simply call radio. We have a radio media, and then we have a category code, unguided media. But how about copper? Previously, we don't mention copper, but we have a copper. And the fiber coaxial cable, the other. And we can have a category code, guided media. Here, we have the guided media. And I think you know we have the twisted pair, one possible guided media. And we have a cable guided media. And actually, if we want to know a bit more about cable, we have two concentric copper conductors and bidirectional, 双向. And we have the broadband feature for the cable. So that's why we use cable to provide a higher transmission rate. If we have a DSL, a bit lower transmission rate. Well, right now, because we want to have a higher one, so of course we prefer coaxial cable. So that's why previously we have the cable to provide one possible residential access network. So this is the possible guided media. And actually, if we want to have an even higher one, we can try fiber. So that's why we have fiber and coaxial, so put them together. We have HFC, right? Here we have the individual cable and the fiber. And previously we have HFC, so we have a bit higher one, so we have HFC. Well, why fiber can provide an even higher one? Because we have a low error rate, and so that we can transmit faster. Well, and radio, previously we already have a Wi-Fi and 4G, and right now we go through radio quickly. And radio, we just want to let you know, in fact, to have a radio, and we transmit here, maybe no obstacles. However, well, how about the door? So possibly you use radio, then we may have obstacle, and then we have the possible phenomenon, diffraction, refraction, and the others. And in fact, we want to emphasize interference, and so that we have some limitation. Because of this limitation, so that's why normally about transmission rate for radio a bit lower than Ethernet. And we already have Wi-Fi and 4G, 5G, and in fact we have the others. How about satellite? How about terrestrial microwave? Yes, in the past we have the application of terrestrial microwave, but we don't emphasize that one. We simply emphasize Wi-Fi and 5G because these are frequent applications. However, how about satellite? Satellite, we have one feature. If you want to have the transmission, then you need to have the necessary time. 260 milliseconds for the end-to-end delay because long distance. However, even long distance, satellite can provide the global coverage. Well, in the future, cellular network expect to have the global coverage. However, not really easy to reach it. Even in the past, we have a satellite already. However, we don't achieve it. We don't have the mature explosion of satellite. So 5G here expect to include the possible transmission based on 6G, based on satellite. And so that if we have the new generation 6G expect to incorporate satellite as one possible solution. So satellite should provide the broader coverage. Coverage says we can have this area wider than cellular. So we have even larger coverage. So of course we expect that one for sure. So in fact we can have a satellite and for example satellites. How about the project by one, it should be called X. The boss of X actually provides some project about satellites, right? And why he wants to provide some possible technique based on satellite? Because it's the new direction for 6G. So yes, it's satellite. Well, so we check network edge. That you have some more details about host access network. And finally, we go through quickly about the physical media. Well, maybe you think it should be the start of chapter 1 and currently checking the path of mine. Maybe let me check with some of you. How about the path of current lecturing? Okay, or a bit fast or a bit slow? The pace? Yeah.
Oh, I think the pace is okay.
The path is okay, right? From the viewpoint of her. And how about Taiwanese? 目前讲话的速度快慢？正常。但我认为我好像一直在赶，对不对？有没有感觉这样？还是我演示的很好？ I think maybe I go through quickly, but maybe most of you think, okay, the path is okay. If so, that's good. So let me continue because I try to reach at least to 50. My goal for me to reach 50, and so that I can catch up the possible schedule I set. So if you feel, okay, why you speak so fast? If you think so, forgive me because I think the current introduction material should be the simple one. So allow me to go through possibly quickly. So I finished the discussion, what's the internet protocol and network edge, and right now let's check the details about network core. For core of the network, actually we have the interconnected routers. And the interconnected routers, you can call, they form a net. But here we use a different term, it's mesh. Mesh means, oh, okay, all the components can connect each other. So we have a mesh of interconnected routers. And for the interconnecting routers, in fact, we can have the possible technique to exchange the message. Previously, we also mentioned packet. Yes, one of the possible techniques based on packet, so we can use packet switching. Well, packet switching actually we based on splitting or breaking application layer message into packets. And then we can exchange messages through sending packet, and packet. Based on packet so that we can have the exchange way. So we call that technique packet switching. Well, so then for the goal here, packet switching, just forward the packet, and expect the packet can be successfully received by the destination. All right, so forward packet, destination, you see. Well, so the simple idea for packet switching, we need to store. Well, currently I have the packet stored here. If it can be transmitted, then forward. Store and forward using the simple idea store and forward, and guarantee store and forward can reach the next hub and reach the next hub, finally reach the destination. So it's possible to allow the host to send a packet to the router, or maybe allow the router finally reach the destination. However, the current example, we expect one router in between the source and destination. And previously, we already have the definition of transmission delay, right? And the transmission delay, we have a specific term. Push out. I already have the description, move the packet from the host to the transmission line. It's somewhat like, okay, for the host, we want to push it out to the transmission line. So that's why we have the term push out the packet to the transmission line. And this time it's called the transmission delay. Well, but based on transmission delay, why we want to talk about store and forward? In fact, we want to know time from maybe the time instant transmit the packet and until it reaches the destination. So we want to know that time. So how to have for that time? Then we have for the end-to-end delay. And the end-to-end delay should be the time for the store and forward mechanism. Well, we already have the answer. 2 multiply L over R. Why? First of all, move from source to the first transmission line, and then router move it from router to the second transmission line. So of course 2 times. And should we have the propagation delay currently? No, we set it to 0. Should we have the other delay? No, we set it to 0. So current consideration will just care about transmission delay. And so that we simply have 2 multiply the transmission delay L over R. Because of we ignore the propagation delay and the other types of delay. In fact, we have the other types of delay. So that's why we have the simple delay 2 transmission delay. 2 times of transmission delay 2 multiply L over R. Well, of course, we may have some example, and I think the example it's easy, so I let it know that one simply. And if yes, L over R, 1/2 transmission delay should be 0.1, right? And 2 should be 0.2, and that's it. Well, we have these. Well, transmission delay, let me try because my pen cannot work properly. Let me try it again. So let me use the other way to have the discussion. So the other discussion, let me try. Is it okay? Yes. So I use PDF to have the discussion because something wrong with the PPT slide. So let me move on to this one. Because I moved to the current page, we don't have live subtitles. So let me start the possible example. So previously we have this, the simple example. We have a source. Okay, we have a source. And then we have a router. And so that we have a destination. I use a different way to illustrate how we have the time. First of all, we have axis. It's time axis. So this is time L over R to generate or to push the packet to the link. And because of zero propagation delay, so we have the horizontal line, then we reach it. And likewise, we have L over R again because we have R and R here. So we can reach the destination. For the destination, we receive it and then everything's done. So we don't have the transmission delay. And start from the current time 0, and the current time maybe 2. So difference T2 multiply T0, we have L over R plus L over R. This is the current solution. However, I try to emphasize to use the time axis here, time axis. So we have a time axis. All right, time axis here, so you can have the time calculation. About the current illustration, is okay? In fact, previously we just have L over R and multiply 2. But currently, I already have the zero propagation, so we have the horizontal line. Well, if it is not the zero propagation, for example, we have the propagation time. Non-zero propagation delay. So you should have this again. And maybe a different one. Non-zero, maybe propagation 1 and propagation 2. And so that the time should be same. T2 minus T1 should be 2L over R plus propagation 1 and propagation 2. If I assume propagation 1 and 2, they are not the same. And right now, maybe you don't have any idea about propagation delay, so I just let you have the notation, propagation delay 1 and propagation delay 2. So, oh, 0, yes, you are right. So I assume we have a propagation delay. So this is a drop. The drop denotes the propagation delay 1 and the drop propagation delay here 2. So we should have the actual propagation delay. But currently, I don't mention how we have the calculation for the details of propagation delay. We just mentioned we have the amount for first propagation delay and second propagation delay. Well, I already have two different scenarios. Scenario 1, transmission delay only. Scenario 2, if you want to consider propagation delay. And actually for all the derivation, I sent it to the YouTube so you can recheck the video for sure. So it doesn't mean, okay, if I miss the details, it doesn't matter. You can recheck the video. I think I sent it through the streaming. And this one, okay, right? So I can erase all. Maybe I not erase all, but I erase this. So same. Even you think, oh, it's messy. However, I try to make it easy. So I have the change. So I have the color. How about transmission rate 1? And how about transmission rate 2? And so that we have this one only 1 and 2. And so that this one not 2. We have L over R1 and L over R2. So this one replaced 2 times. Is okay? Same, if you still want to check all the details, you can check the recorded video to check the possible answer. But here I change transmission rate R to R1 and R2. So we have the individual sum. Sorry, we have sum for the individual transmission delay. So that we have sum of propagation delay 1 and 2. Oh, sorry, transmission delay 1 and 2. So we have the new formula. About this, it should be okay, right? And furthermore, I should erase some of them. I still assume we have R and R. But, oh, all right, right now we have, for example, this one, previously a single packet, but right now, ten packets. Previously, we just consider 1 packet. And right now, we consider, how about given 10 packets simultaneously? So you want to send 10 packets and then finish the exchange. So we have the first one. wait a moment. Yeah, maybe because of a low battery, so sometimes it cannot work properly. But I think right now it's okay. So how about 10 packets? We have 2 L over R, and right now we multiply 10. Right? So if we have 10 packets simultaneously, the time to the final one reach the destination, we should have 2 L over R multiplied 10. Is it okay? I think you can notice we have some specific discussion. The actual discussion here. So I think for the current one, you know, we should have a 10, but why? I didn't know here. First one, second one, third one, fourth one, to the 10th one. And likewise one, oh sorry, something wrong, sorry, I should have the correction. Sorry, this is the first one, and then for the others, it should be 2L over R, 8, 9L over R. It should be the correct one. So, sorry, let me have the correction. For this one, 10, we pass on 10, so we allow them, okay, finish transmission, you can send the others. If we have 2L over R multiplied 10, that says, we know this one finished and then I allow to send. So, sorry, previously, I don't have the figure, so something wrong. So this one should be the correct one. Transmission delay, so reach it. So we can have the next transmission. So then we have the label 1 to 10 and 1 to 10. And for the remaining, actually just 1 L over R difference. So it should be first one, and for the remaining 9 packets. And each one we have the separation, it's L over R. So finally it should be this. So let me emphasize this again. This one wrong, and this one correct. And we will continue for the discussion this Wednesday, talking about this. And I didn't have all of the actual discussion, so if you fail to have all at least, I think you can check the video after classes. Is it okay? So don't worry, you still can have the result after checking the video. I think you can check it because I use the streaming, so you can check it directly. And of course, a day later, I will trim the head and the tail, and so that I will remove unnecessary part of the video, only for that, and nothing else. So you can check some of the content by yourself. Well, I think I should stop here. Before you go, let me make sure any questions. Even I cannot reach page 50. I think I have the actual discussion, so I will stop here for a while. And this Wednesday, actually I have the other. I will continue. Well, about the current discussion, you can check the video, and even you have questions. This Wednesday, I will check it with you. Well, any questions? If no, see you. Bye-bye.